Hey everybody, welcome back. This is lesson 4 in Unit 7, and today's lesson covers solubility curves, which is found on table G on your chemistry reference table. So in the last video, we talked about factors affecting solubility, so factors that change the amount of stuff you're able to dissolve. And so we're going to use some of that and go into more detail today. So again, we're going to use kind of some of what we learned yesterday or in the last video to cover solubility curves and how to read them and what they mean. So temperature is a huge thing when we're talking about solubility curves, and we had talked in the last video that the solubility for solids, for just about most solids, increases when the increase in temperature. So if you have a higher temperature, you're able to dissolve more stuff. And so if you think about making coffee or something, if you buy a nice coffee at Dunkin', you get that inch of sugar on the bottom. But if you get that hot coffee with the same amount of sugar, there is no lump of sugar on the bottom because of that higher temperature, more stuff can be dissolved. But it was opposite for gases. So the solubility of gases actually decreases when you increase temperature. So again, think of an ice cold soda versus a warm soda. Ice cold soda, when you drink it, every sip you take has bubbles in it because those bubbles are the gases that were dissolved in the soda. But if you drink warm soda, there's very little bubbles because all the gas escaped because it's no longer soluble. So this is table G. And so a few things that you should notice is, all the temperature is increasing, going up. And we see, this is a graph of like 10 different things at once. So it looks a little bit scary, but we're only going to look at one thing basically at a time. It's also given 100 per 100 grams of water. So what the y-axis is showing you, this is like 10 grams of whatever substance dissolved in 100 grams of water. So it's whatever this number is dissolved in 100 grams of water, and that's pretty much it. You'll also notice that most of these curves go up, have this upward trend to them, but we have this one, which is HCl, which goes down. We have SO2, which goes down, and we have NH3, which goes down. So those three are gases. So if the solubility goes up when temperature goes up, those are your solids. If solubility goes down when temperature goes up, those are your gases. So it would be a good idea to first just highlight each path a different color so it's easier to read, and then just make note that HCl, NH3, and SO2, the ones that are going down, are gases. And so when we're talking about these curves, every part of the graph, even if you're not on the line, it means something. So it's kind of like Goldilocks and the Three Bears. So the curve itself, the line, that is saturated. And so saturated means, you have the definitions here, you are holding the maximum amount of solute that you can. You cannot hold any more. So if you think of it like if you're carrying eggs, you buy a dozen of eggs, 12 eggs fit in the container, that is it. It cannot carry any more. And so that's your saturated line. But if you're under the curve, so here's the curve, we're going to talk about being on the curve, above it, or under it. If you're under the curve, you're unsaturated. So under is unsaturated. And so what unsaturated means, we're talking about this one now, is that you still can dissolve more stuff at that given temperature. So let's say, going back to the egg example, it can hold 12, but you only have 6 eggs in there. It does have the potential to hold more. That's unsaturated, so under the curve. And then our last location is above the curve. So if you think of, Superman flies above stuff, so supersaturated is above the curve. And so what supersaturated means is that there's more solute that can be held at a stable kind of thing. So basically you have too much stuff dissolved in it, and it becomes this very unstable solution, and when it's disturbed, you kind of knock or precipitate everything out. This is actually how rock candy is made, and it's something we might go into later. So supersaturated, you're holding more than you can. It's very unstable. So in that, again, egg example, your container holds 12. But let's say you balance, 6 more eggs on top. Not very stable. You touch it the wrong way, stuff happens. So on the curve is saturated, under the curve is unsaturated, above the curve is supersaturated. So again, here's another picture that we can look at. Unsaturated, you can dissolve more stuff. Saturated is just right. You cannot dissolve anymore and have that stable solution. And supersaturated, you have too much and you start forming these crystals. So again, here is table G, and I highly recommend that you, on your own reference table, I'm going to run out of colors, just highlight or color each line a different color so it's easier to kind of follow, because generally you'll only be looking at one curve at a time, but if they're colored, it will be easier to see. Okay, so kind of like that. It's a very colorful thing. So let's jump into some questions. There's about 5 types of questions generally that you'll be asked about pulling data off of this curve. And so one of the simplest ones is my question number 1. How many grams of KNO3 can be dissolved in 100 grams of water at 70 degrees Celsius? So we're looking at KNO3. And so your first step is to find the KNO3 line. Again, I'm going to highlight that red. And so we're just going to focus on this line. Everything else in this curve is just there as a distraction and will not help us. Okay, so it's 100 grams of water. So that's that. So it's how much can we dissolve, what number on this axis in 100 grams of water. So if you see in 100 grams of water, that's exactly as table G has it at 70 degrees. So basically it's asking you to go up at 70 degrees. When do you hit the line? Hit it right about there. And so when you drag that over, how much is that? So what value is that? I say it's halfway between 130 and 140. So I would say that's 135 grams. And that's it. It's just pulling data points off of a graph. So again, things to point out, 100 grams of water, if you see that in the question, that's exactly how table G has it. No other fancy things you need to do. Okay, question 2 is the same question, so we're still going to look at KNO3. So we're still looking, I'm going to make it green this time. Still looking at this one. And we're still at 70 degrees. But now it says 200 grams of water. And so again, we're given 100. So if you double the amount of water, you're able to double the amount of things. So what you're going to want to do is 1, find amount in 100 mils of water. So the normal way. And then double amount because you doubled the water. So we had said before, I'm going to grab, let's say orange. We went up. We got 135 grams in 100 milliliters. And if we're doubling the water, so we have 200 mils, we can double that. So 135 times 2 is 270. 270 grams in 200 milliliters. So again, if you're doubling the water, you have to find what it is first on the graph and then double it. So that's one way the questions can kind of trick you on this. Again, we're going to look at all the different variations of this. We're still looking at KNO3. So let's make it purple this time. Still looking at 70 degrees. But now we're looking at 50 grams of water. So here we halved the water. So whatever value we get, we're going to half the solute amount. So again, at 70 degrees, if you go up, 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 and go across, again, we have 135 grams in 100 mils of water. And so if we have half the water, we're going to cut that in half. So in 50 milliliters, 135 divided by 2 is 67.5 grams. And so that's it on that part. So again, if you have the water, you have the amount of stuff you can dissolve in it. Okay. Another type of question is something that looks like this. So if a saturated solution of NH4Cl is prepared at 80 degrees and then cooled, how much NH4Cl will crystallize? So now we're going to look at NH4Cl, which is this blue line here. And so if it's giving you two temperatures and asking you how much is crystallizing, it wants you to kind of look at the before and after values. So at 80 degrees, you can hold, bring it across. I'm going to say at 80 degrees, it's about 67 grams. Again, as long as you're somewhat within a reasonable thing, you're fine. And then it says at 20 degrees. So at 20 degrees, we go up and say at 20 degrees, oops, I say that's about 38 grams. And so basically what it's saying, you made a saturated solution at 80 degrees, but it cooled. So the problem is that you have this much amount of sugar in that orange dot, where this orange dot is, but according to this curve, you can only hold a maximum of 38. So all of this extra sugar in that area recrystallizes. So what you're going to want to do is just do 67 minus 38, because you want to figure out how much sugar in this area, came out of solution and crystallized. So 67 minus 38 equals 29 grams. Sorry, it was saying sugar, it's NH4Cl. So you have 29 grams of NH4Cl that is being crystallized. This is very much how rock candy is made, and so that is why I was mentioning sugar. Same very concept. Okay. Last type of question. If you were given 15 grams of KClO3, so we're dealing with this curve, where is it? KClO3. Okay. This one. If you're given 15 grams, how many more grams would you need to make a saturated solution at 100 degrees? So at 100 degrees, it's over here, a saturated solution. So saturated, remember, means on the curve. You need 60 grams at 100 degrees, but you have 15 grams. So how much more? So you're basically right there. So currently, we would say that's an unsaturated solution because it's under the curve. So if you have 15 grams and you can make a saturated solution with 60 grams, how much more do you need? 60 minus 15 is 45 grams. And that's it. So again, these are the 5 types of questions you'll see with this. Question 1 is your very, very basic, pick a number off a graph. 2 and 3 kind of show variations of that, and then 4 and 5 are different kind of types, but they all generally work the same way. And so that's it for table G. Again, this just kind of takes practice looking at. I do highly recommend the color coding just so it's easier for you to kind of keep track of stuff. In the next video, we will cover concentration. There's a few different concentration calculations we're going to cover, but we're going to cover it in 2 parts. So next video will be part 1, covering molarity. So on that note, that is it.